progressions and its introduction. So now we are going to discuss about a new topic, that is progression and its introduction, and under the introduction part, which we are going to deal in an advanced level. So we will discuss about the terms such as sequence, and in which we will deal about the finite sequence, infinite sequence, real sequence, and the terms present in that particular sequence. So first of all, let us discuss about the first one, that is the first topic, which is said to be called a sequence. So here a sequence, it is a collection of numbers that are arranged in a certain order and are formed according to a rule. Then it is said to be called as a sequence. When it consists different number of terms in it, then it will be called as a finite sequence. If it has infinite or indefinite number of terms, then it will be called as an infinite sequence. So first of all, a sequence, it is a collection of numbers that are arranged in a certain order and formed according to a rule. Say according to rule, the numbers are arranged according to a rule, then is said to be or is known as, is said to be a sequence. So in a sequence, we will collect numbers and we will arrange them in an order according to a rule. Then such a rule in which the collection of objects are arranged in an order is said to be called as the first one, that is the sequence. Then now the second one is of finite sequence. So in the finite sequence, particularly that sequence will consist a definite number of terms in it. Then such a sequence is said to be called as a finite one, or in other words, a finite sequence. So here a sequence consisting a definite, or in other words, it has a particular number of, finite number of, or in other words, definite number of terms in it. Is said to be a finite sequence. See, under this finite sequence, so let us write one example. So example under the finite sequence. Odd numbers which are less than or equals to 15. So 1, 3. So 1 is the least odd number. So very next successive odd number is of 3, 5, 7, 9, 11, 13 and 15. So these are the odd numbers which are less than or equal to 15. So it will come under a definite because it has. So here 3 and 3, 6 and 8. So here there are of 8 definite number of terms in it. So it will come under the finite sequence. Then now the next one is of infinite sequence. So it is a sequence with infinite number of terms in it will be said to be an infinite sequence. So here a sequence with indefinite or infinite, both gives the same meaning here, indefinite number of terms in it is said to be, or is known as, is said to be an infinite sequence. So here let us perform one example under this infinite sequence. Example, infinite number of odd even numbers. So here 2, 4. So here least even is of 2. The very successive even is of 4, 6, 8, 10 and dash dash. It is an infinite sequence. Then now coming over to the next one, that is the fourth one, is of real sequence. So real sequence is a sequence with all real terms in it, which is said to be called as a real sequence. Whereas here the terms in the sequence are of real, then such a sort of sequence is said to be called as a real sequence. A sequence with all real terms present in it or in it is said to be a real sequence. Then now here we discussed about the terms present in the sequence. So let us, the different numbers in that particular sequence are said to be called as the terms in that particular sequence. Then now next one, so we are going to the fifth one, which is nothing but the terms of a sequence. So here the different numbers in that particular sequence will be called as the terms of that sequence. So now the different numbers in a sequence is said to be a term of a sequence. Is said to be terms of that particular sequence. Is said to be called as the terms of a sequence. Generally, so here these terms are denoted by T1, T2 and T3 and so on. So here we can write it as note. So here the terms are generally denoted by T1. So here generally terms of a sequence, or in other words series, are denoted by T1, T2, T3 and so on. Whereas in it T1 will be called as the first term and T2 the second term, and whereas if it is of Tn, then it will be called as the nth term. it is the nth term of the sequence, or in other words it will be called as the nth term of the series. In case if you straight away if you write the nth term as 2n plus 3, so here let us perform one illustration. One illustration under this. So here if we straight away write a nth term, so here generally nth term is denoted by say Tn as 2n plus 3, then the corresponding sequence for n is equals to 1, 2, 3 will be as follows. Then the corresponding sequence for n is equals to 1, 2, 3 and dash 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 is of. So here in other words, when the nth term is given by means of 2n plus 3, then what will be the corresponding sequence then? If n indicates the natural numbers, that is 1, 2, 3 and so on, then the sequence is of what? Then what will be the sequence which we get? So here for that let us perform. So as per the note which is given is of Tn, the nth term is given as, the nth term is of 2n plus 3. If nth term is given by means of 2n plus 3 at n is equals to 1, when n is equals to 1, then what will be the first term of the sequence? So here t, so here n must be replaced by means of 1 in the present or the given quotation. So here then t1 equals to 2 into, so n is of 1, so here n must be substituted or replaced by means of 1, then now plus 3 must be written as it is. So that implies 2 ones is of 2, then plus 3, then that is equals to 2 plus 3 is of 5. So in this manner, say I got the first term as 5. Therefore, the first term of the sequence when the nth term is of 2n plus 3 is of 5, whereas n belongs to the natural numbers. Then now, so here let us write the given condition as it is. The given condition is of Tn is equals to 2n plus 3. Then now let us replace n by means of at n is equals to, now let us take 2. When n is equals to 2, then the second term of the sequence will be of, so here n must be replaced by means of 2, then that is equals to 2 into, so n replaced by means of 2, so within brackets, then now plus 3 written as it is. So that implies 2 2 is of 4, then now plus 3, so 4 plus 3 is equals to 7, so 7 is the second term. So in this manner I say I got, so here second term, so T2 as 7. So similarly, so here nth term is of 2n plus 3, which is given first, then at n is equals to 3 now, then the third term will be of t, n must be replaced by means of 3, then that is equals to 2 into n again replaced by means of 3 within the brackets, plus 3 must be written as it is. So that implies 2 3 is of 6 plus 3 written as it is. So that implies 6 plus 3 is of 9. So in this manner I say here 9 is the T3, that is the third term. So in this manner we got third term as 9. Therefore, hence the sequence or the series is of, the first term is of 5, the second term is of 7, and at the same time and the third term is of 9. Therefore the sequence will be of 5, 7, 9 and dash dash.